This is another video featuring astronomical images I've been able to capture with my smart telescopes. For some background on my history with astronomy, my equipment, etc., please see the introductory video to this series, link at the top right of your screen. I hope you'll excuse I have a bit of a sore throat, so my voice isn't great today. This is part 2 of my attempt to show some of my results from imaging galaxies with my smart telescopes. Please see part 1 of this video, link at top right, for an introductory discussion of galaxies and their observation, some images of galaxy groups, and some images of individual galaxies. In this video, I will continue with more images of individual galaxies that I've been able to obtain in the past year or so, with more galaxies from the Messier catalogue first to be featured. Here's an image of M51, the Whirlpool galaxy, from 24 minutes of exposure with my unistellar Equinox to 4.5-inch reflector on June the 2nd, 2025, with no filter. This version was output as the final image by the scope's own software. Here's a version of that same image after I did some processing in Galaxies, Cyril and GIMP. The left side of the image is out of focus due to the scopes having collimation issues. And here's a version, again from that same observation, but stacked and processed from the raw frames. The collimation issue is even more evident in this version. Here's an image of M51 from 30 minutes of frames captured with my C-Star S50 on July the 16th, 2025, with the S50's IR cut filter. And here's a version stacked and processed from the raw frames of that observation. Quite a difference, but still limited by the restricted pixel size of the S50 images. Here's an image of M51 from about 17 minutes of capture with my Vespera Pro 50mm apochromatic refractor on March the 7th, 2025, with no filter. The galaxy appears much smaller because this image spans a much wider area of sky, about 1.6 degrees square. Here's an image of M51 from about 16 minutes of capture with my Vespera Pro on March the 23rd, 2025. This image includes quite a number of faint galaxies in addition to M51. This annotation from Cyril flags additional galaxies from the new general catalogue and the index catalogue. Here's an image of M51 from 15 minutes of 15-second frames captured with my Celestron Origin on January the 26th, 2025, with no filter. This is the final image output by the scope's own software. And here's a version stacked and processed from the raw frame data of that observation. Getting there, but I think I've managed to do a little better. In this image, at least 3 other faint galaxies can be seen: the blurry cigar at centre right, the similar smaller cigar midway over towards the Whirlpool, and the blurry blob at bottom right. Many distant galaxies can be seen like this, especially in summer when looking towards nearby clusters of galaxies. Nearby in universal terms, still vastly distant, of course. Here's an image of M51 from 20 minutes of frames captured with my Celestron Origin on July the 18th, 2025, no filter. I'm rather surprised that the scope's own software has left a satellite trail right across the image. This version was created by my processing of the scope's own output image. And here's a version stacked and processed from the raw frames of that same observation. I've left out the satellite trail. I omitted the frames with the trail from the stacking. Finally, on M51, which is perhaps my favourite galaxy target, here's an image from 30 minutes of capture with my Celestron Origin on June the 28th, 2025, with no filter. This version was produced by applying additional processing to the scope's own output image. And here's a version stacked and processed from the raw frames of that same observation. The Whirlpool galaxy has been one of my favourite deep sky objects to view and image since I started with telescope astronomy back in the 1980s. It's beautiful to observe optically with a dark adapted eye in a dark sky, and its structure comes out clearly in images. The Whirlpool is a classic spiral galaxy about 90% the size of our own Milky Way, which is a barred spiral, located somewhere around 30 million light-years from Earth, so the light by which we now see it left it long before humans evolved on Earth. Visually, it is located in the constellation Canes Venatici, the hunting dogs, which designation does not date back to antiquity, having only been applied in the 17th century. The spiral galaxy can clearly be seen to be interacting with another smaller dwarf galaxy. This is much less unusual than you might expect, although this is the clearest example readily viewable in small telescopes. Galaxies are not at all evenly spread throughout the universe, rather they exist in clumps and filaments with mostly empty space between, and in these clumps and filaments galaxies often interact gravitationally and collide and merge. Studies of the chemistry and velocity of thousands of stars in our own Milky Way have been analysed to show that the Milky Way has collided with and absorbed at least 5 smaller galaxies over its billions of years of history. Next on the menu are a pair of gravitationally associated Messier catalogue galaxies in the constellation Ursa Major, the Great Bear, M81 and M82. Here's an image of M81 from 15 minutes of capture with my Celestron Origin on December the 13th, 2024, with no filter. And here's a version stacked and processed from the raw data of that observation. Here's an image of M82 from 15 minutes of capture with my Celestron Origin on January the 27th, 2025, with no filter. And here's a version stacked and processed from the raw data of that observation. M82 is quite an unusual galaxy. Current theory is that strong gravitational interaction with its companion M81 has disrupted the structure of M82 and also accelerated the condensation of its clouds of gas and dust to create stars at an enhanced rate. M82 is an irregular galaxy which we are seeing almost directly edge on, so not a lot of structure is visible. Because of its shape, this is also sometimes known as the cigar galaxy. I wanted to get an image showing M81 and M82 together in the sky. This is the best I've been able to manage so far from about 11 minutes of capture in less than ideal conditions on March the 6th, 2025 with my Dwarf 3. M81 and M82 are a pair of gravitationally entangled galaxies. These two galaxies were first observed and documented by German astronomer Johann Elert Bode in 1774. Not sure if I'm pronouncing his last name right there, but the nature of the galaxies beyond our own was not understood at that time, so they were known for a century or more as Bode's nebulae. This pair of galaxies was independently observed and documented by Charles Messier's colleague Pierre Méchain in 1779, and Messier added them as the 81st and 82nd objects in his catalogue of non-stellar objects, hence their designation as M81 and M82. M81 and M82 are visually located in the northern circumpolar constellation Ursa Major, the Great Bear. Physically, they are located about 12 million light-years from Earth. M82 is also known as a starburst galaxy, as it is undergoing an exceptionally high rate of star formation. This doesn't show visually in an image from a small scope such as this. Here's a version of that image annotated by Cyril. There are a couple of other faint galaxies flagged in the frame. I tried to image the group of galaxies around M96 using my Vespera Pro 50mm refractor on March the 23rd, 2025, but I gave up because it didn't look from the scope's preview as though I was getting anything. However, I should have persisted, as the galaxies are definitely starting to come out. Here's a version from the raw frames, only 7 stacked, though only 70 seconds of exposure because I gave up quickly. And here's the upper part of that image annotated by Cyril. This is quite an interesting group of galaxies, including 3 from the Messier catalogue. M96 at centre is an intermediate spiral about 31 million light-years from Earth. M95 at centre right is a barred spiral about 33 million light-years from Earth, and M105, the rightmost member of the group of three at top left, is an elliptical galaxy about 37 million light-years from Earth. These galaxies are seen in the constellation Leo, the Lion. These galaxies were all first observed by Pierre Messier when working with Charles Messier in 1781. Here's an image of M100, also known as NGC 4321, or the Mirror Galaxy, from 15 minutes of exposure with my Vespera Pro 50mm refractor on March the 22nd, 2025, with no filter. This version is processed from the scope's own final image. And here's a version stacked and processed from the raw frames of that observation. M100 is a grand design intermediate spiral galaxy in the southern part of the mildly northern Coma Berenices. It is one of the brightest and largest galaxies in the Virgo cluster, and is approximately 55 million light-years from our galaxy, and is about 166,000 light-years in diameter. It was discovered by Pierre Messier in 1781, and 29 days later seen again and entered by Charles Messier in his catalogue of nebulae and star clusters. It was one of the first spiral galaxies to be discovered, and was listed as one of 14 spiral nebulae by Lord William Parsons of Ross in 1850. Here's an image annotated by Cyril. Quite a number of faint galaxies are seen around M100. Here's that annotation with the very faint index catalogue galaxies removed. Those appear only as faint dots. NGC 4323 and NGC 4328 are satellite galaxies of M100. The former is connected with it by a bridge of luminous matter. Here's an image of M101, the Pinwheel Galaxy, from about 15 minutes of exposure with my Equinox 2 reflector on March the 17th, 2025. The scope was going out of collimation, so the left side of the image is out of focus. The pinwheel didn't come out well from 15 minutes with this scope, though you can certainly see the shape almost as you might see it in a good amateur optical scope. Here's an image of M101 and surroundings from about 15 minutes of exposure with my Dwarf 3 on July the 4th, 2025, with the Dwarf's Astro filter. And here's a version stacked and processed from the raw frames of that observation. This shows the pinwheel in context quite nicely. The fuzzy round object just left of bottom centre is NGC 5474, an odd dwarf galaxy that is a companion to M101. Here's an image of M101 from about 18 minutes of exposure with my Vespera Pro on March the 6th, 2025. And here's a version stacked and processed from the raw frames of that observation. Here's another attempt with the Vespera Pro, about 16 minutes on April the 9th, 2025, with no filter. And here's a version stacked and processed from the raw frames of that observation. Here's the central region of that image annotated by Cyril. The label for NGC 5474 is just going off at the right. This galaxy does look rather like the Owl Nebula M97. Here's an image of M101 from 36 minutes with my C-Star S50 on June the 16th, 2025. This is the final image output by the scope's own software. And here's a version stacked and processed from the raw frames of that observation, getting closer to a good view of the pinwheel, but the S50's image resolution is limited. Here's an image of M101 from 15 minutes of exposure with my Celestron Origin on January the 27th, 2025. And here's a version stacked and processed from the raw frames of that observation. Here's another attempt with the Origin, 20 minutes of exposure on July the 18th, 2025, with no filtration. This version was stacked with Deep Sky Stacker, though I more usually use Cyril for stacking. Here's a version from that same observation processed from the output image generated by the scope's own software. And here's a version processed through my most usual practice, stacked with Cyril from the raw frames, then processed with Graxpert, Cyril, Cosmic Clarity and GIMP. This galaxy was first observed and noted in 1781 by Pierre Messier, Charles Messier's colleague. He was not able to see its spiral structure in the telescope that he was using and recorded it as a nebula without stars, very obscure and pretty large. It wasn't until nearly 100 years later, in the second half of the 19th century, that the spiral structure was first noted and sketched by Lord Rosse, using a telescope with a 6-foot mirror. That's 6 feet, whereas my current largest scope has an aperture of 6 inches. M101 is now known as the Pinwheel Galaxy because of its spiral shape. Note that the spiral arms are far from symmetrical. M101 is part of a small group of galaxies, but the others in the group are faint and hard to observe. Gravity from other galaxies in the group accounts for the asymmetric structure of M101. The Pinwheel is a large galaxy, around twice as far across as our Milky Way. It is estimated to contain around 1 trillion stars. Visually, it's located in the constellation Ursa Major, the Great Bear. Physically, it is located around 21 million light-years from Earth. So again, this image of the galaxy was made with light that left there long before humans evolved on Earth. Moving on to another Messier galaxy, here's an image of M104, the Sombrero galaxy, from about 12 minutes of exposure with my Vespera Pro on April the 9th, 2025, no filter. And here's a version stacked and processed from the raw frames of that observation. Another attempt from the Vespera Pro, 15 minutes of exposure on March the 22nd, 2025, no filter. And here's a version stacked and processed from the raw frames of that observation. The Sombrero galaxy, catalogued as Messier 104 and NGC 4594, is a peculiar galaxy of unclear classification, seen near the border between the constellations Virgo the Maiden and Corvus the Crow. It is physically located about 31 million light-years from Earth. It is a member of the Virgo Southern Extension, a series of galaxies strung out from the southern edge of the Virgo supercluster. This galaxy was first observed and documented by Pierre Messier in 1781 and later independently observed by William Herschel in 1784, who was the first to note the presence of the dark dust lane across the galaxy. Moving on, here's an image of M106, the last Messier galaxy I'll be featuring in this video, though there will be a glimpse of M58 as a little blob later. This image is from 15 minutes of capture with my Celestron Origin on January the 27th, 2025. And here's a version stacked and processed from the raw frames of that observation. And here's a version after a bit more processing. Not really much detail to see in the structure. There are several other faint galaxies in this frame. The Cyril annotations here have picked up 4 NGC galaxies, and I can see quite a few other things in the frame that I'm fairly sure are galaxies. M106 is an intermediate spiral galaxy, another of Kant's island universes, visually located in the constellation Canes Venatici, the hunting dogs. Physically, it's located about 24 million light-years from Earth, so again we're seeing light from way before human history. Its designation M106 comes from the fact that it was the 106th object in the final version of Charles Messier's catalogue of non-stellar objects. M106 was actually discovered by Messier's colleague Pierre Messier in 1781. This galaxy is apparently very interesting to professional astronomers as it has various features detectable in large scopes and different spectra, for example X-rays. There is a massive black hole at the centre of the galaxy. Water megamasers have been detected in this galaxy, which allow for observations useful in confirming the galactic distance scale. Here's an image of a visually quite similar galaxy, NGC 2403, from 15 minutes of exposure with my Celestron Origin on January the 26th, 2025. And here's a version stacked and processed from the raw frames of that observation. And here's another image of NGC 2403 from 20 minutes of exposure with my origin on December the 14th, 2024, no filtration. NGC 2403 is an intermediate spiral galaxy visually located in the constellation Camelopardalis, the giraffe, so named in the early 17th century. The plane of this galaxy is tilted to our line of sight at an angle of about 40 degrees or so, making it rather hard to make out the spiral structure. This galaxy was first observed and documented by William Herschel in 1788. It was the first galaxy outside the local group in which Cepheid variables were detected, allowing fairly accurate calculation of its distance. Although it took a while to sort out the observations, identify the correct stars, and get the calculations right, so it wasn't until the late 1960s that the distance was confirmed, and it still might be anywhere between 8 and 10 million light-years. NGC 2403 is part of the M81 group of galaxies. Here's an image of NGC 6946, the fireworks galaxy, from 20 minutes of exposure with my celestron origin on July the 25th, 2025, no filtration. And here's a version stacked and processed from the raw frames of that observation. NGC 6946, sometimes referred to as the fireworks galaxy, is a grand design face-on intermediate spiral galaxy with a small bright nucleus, whose location in the sky straddles the boundary between the constellations Cepheus and Cygnus. Its distance from the Earth is about 25 million light-years, similar to the distance of M101 in the constellation Ursa Major. Both were once considered to be part of the local group, but are now known to be near the Milky Way, but beyond the confines of the local group as such. NGC 6946 lies within the Virgo supercluster. This galaxy was discovered by William Herschel in 1798. Here's an image from around 11 minutes of exposure with my Vespera Pro on April the 9th, 2025. I would have liked to expose more, but conditions declined. Here's a version of that image annotated by Cyril to show Messier and NGC objects. The intended subject here was the pair of interacting galaxies at centre. M58 can be seen at the top of the image. Here's a version with galaxies from the index catalogue added, and I'm sure there are more galaxies than that in the frame. Here's a final stacked image without annotations. NGC 4567 and NGC 4568, nicknamed the Butterfly Galaxies or Siamese Twins, are a set of unbarred spiral galaxies about 60 million light-years from Earth seen in the constellation Virgo. They were both discovered by William Herschel in 1784. They're part of the Virgo cluster of galaxies. These galaxies are in the process of colliding and merging with each other. However, the system is still in an early phase of interaction. In perhaps 500 million years, the galaxies will coalesce into a single galaxy. Well, that's it for this video. If you have any questions, either about my equipment and methods or about the astronomical objects imaged, please post in the comments below and I'll do my best to respond. Next will probably be images of some less well-known nebulae, as I've been trying my scopes in that direction quite a bit, and probably some new images of old favourites. Until the next time, clear skies.